Okay, so today we're going to be talking about forces. So I'll start off with an example. So say there's a guy right here and there's a ball right next to him. Both the guy and the ball aren't moving. So let's just assume the ball's mass to be about 500 grams. And since it isn't moving, the velocity would be 0 meters per second. And now with to find acceleration, you just had to divide velocity with time. So acceleration is equal to velocity over time. And here, since velocity is 0, this would equate to 0 over time. Now, we don't really need to know the time here because 0 divided by anything would always give you 0. And in this case, let's just put the units as well, meters per second squared for acceleration. So since neither entity is moving, there's like no force acting between them. The guy doesn't feel the ball, and the ball doesn't exert any force onto the guy. But let's change this a little bit. Say the velocity was 5 meters per second. Oh, sorry, I meant the acceleration was 5 meters per second squared. So the ball would be moving towards the guy at this velocity. And once the ball hits the guy would feel something. Why? Because the ball exerted a force upon the guy. And say this was a different ball in this case. So since this ball has a mass of 500 grams, let's just change it to 5 kgs. So the heavier the ball, it will hurt more, right? Why? Because as the mass of the ball increases, the force exerted also increases. It's like the difference between getting hit by a bowling ball and a football, for instance. The bowling ball would hurt more. So from this example, we can safely say that force, as in the force exerted by any object, would equal to the mass of that object multiplied by the acceleration of the object. The mass, because heavier it is, the more force, and acceleration, because faster it is, also more force. So, yeah, so force is equal to m, stands for mass, multiplied by acceleration. Okay, so using this formula that we have just derived, that force is equal to mass into acceleration, let's just check if it, all sums out. So in the first instance, the force should equal to 500 grams, which is the mass of the ball, multiplied by its acceleration, which was 0 meters per second square. And anything multiplied by 0 would give you 0. And we should also not forget to write the newtons of force, the units of force, which is newtons. Let's take the second instance. So here the force is equal to, the mass is 5 kgs. So let's just change it to grams, which is 5,000 grams, multiplied by the acceleration, which is 5 meters per second squared. You multiply that, it should give you 25,000 newtons. So now we can move on to solve some problems. So here we have a really simple problem. So there's a box at the center and 50 newtons of force is pulling it to the right, while 25 newtons of force is acting in the opposite direction because of friction. And we represent friction using this force, which is the capital F, with a small f under it, which stands for friction, so frictional force. We're ignoring gravity here. So yeah, our job is to find the net force of the box and which direction is it moving. Is it moving to the right or the left? So in order to find that, we can do this. So the force, net force, is equal to 50 newtons minus 25 newtons. So why did I take a minus here? Why did I subtract 25 from 50? Now I did that because 25 newtons is acting in the exact opposite direction of the 50 newtons. So which means that the net force would be minus 25 newtons. If you're looking at it from the same direction, 50 newtons is going at a positive axis while 25 newtons is acting on the negative axis. So we subtract it. So this gives our net force to be 25 newtons. And since it's a positive value, and we took this as the positive direction, which means the box is moving to the right with a net force of 25 newtons. So now let's move to a more challenging question. Okay, so now we have a much more challenging problem. So in this problem, there's a box with a mass of 500 grams just sliding down a slope that is inclined at with an angle of 60 degrees. And here, frictional force is negligible, so we're just going to leave that as 0. And the only force that's acting on it is acceleration due to gravity. So here I wrote mg to denote the force, which is, of course, mass over acceleration. And in this case, acceleration is 10 meters per second squared. So first, let's find the force that's acting downwards. So that's going to be force is equal to the mass, which is 500 multiplied by 10, which is the acceleration, which gives me 5,000 newtons. So in order to find the acceleration, so that's the question here. What's the acceleration of the box that's just sliding down? So in order to find this, we first need to construct a right triangle. As you can see, it kind of makes a right triangle. The gravity is acting downwards, so this is going to be the 90 degrees, and the angle is given as well, 60 degrees. So this is one side, it's another, and this is the hypotenuse. And the hypotenuse is the force that's acting towards this side. And after we find the force, and since we know the mass, it would be easy to find the acceleration. So first, let's just construct this triangle properly. So I have my right triangle here, and this is 60 degrees, that angle. It's just a 90-degree angle, and we know this side to be 5,000 newtons. So by just using basic trigonometry, we can find the hypotenuse. So we have an angle and a side. So this is the opposite side to the angle, and this is the hypotenuse. So we'll use sine, which is what it represents. So sine of 60 should equal to 5,000 divided by the hypotenuse, which we'll just put it as x for now, x. So in order to find x, we take x to the other side. So x is equal to, and we'll take sine towards this side so it becomes sine inverse of 60 multiplied by 5,000 should give me x, which should equal to, okay, so I just noticed that I made a mistake here. It's not going to be sine inverse of 60. No, it's the sine 60 is going to come down. Let me just get this out. Okay, so sine 60 is going to come to the denominator. So this x is actually equal to 5,000 divided by sine 60. And let me just calculate that real quick using my calculator. So 5,000 divided by sine 60 is going to give me 5,773.5, and since it's the force, we're just going to put the units as newtons. So this is the force that's acting in this direction. So this F is equal to 5,773.5 newtons. So now that we know this and the mass of the object, we could easily find the acceleration. So we know that force is equal to ma. So 5,773.5 is equal to the mass, which is 500 grams, multiplied by the acceleration. So in order to find the acceleration, let's just bring the 500 down. So 5,773.5 divided by 500 is the acceleration of the object. So let's use my calculator again. So that's gonna give me so that's gonna give me about 11.55 meters per second squared. And that's it. We have found the acceleration of the object that's moving down just with the force of gravity. So yeah, that's it guys. This is just a brief introduction to forces. Hope you enjoyed.